Welcome back to The Explainer. Today, we're cracking a geographical case. How on earth can one single continent be home to both icy, frozen landscapes and, sun-drenched, almost tropical-looking beaches? We're going to follow the clues to figure out Europe's incredibly diverse climate. I mean, just look at this. On one side, you've got deep snow, you've got cozy cabins, and on the other, beautiful beaches and clear, sunny skies. It seems impossible, but yep, both of these places are in Europe. So how does that work? Let's dig in.
Okay, so to solve any mystery, you first need to understand the basics. Our first question is a big one. What exactly is climate?
Right. It's the difference between saying it's rainy today, which is weather, and it rains a lot in this region, which is climate. Climate is the big picture, right? It's the long-term pattern you can pretty much count on year after year.
So now that we've got our key term locked down, let's take a look at the map of our quote-unquote crime scene. See, Europe isn't just one big weather system. It's actually broken down into really distinct climate zones.
And this is true globally, right? The whole Earth is banded into these different zones. You've got the icy polar regions up top and at the bottom, those moderate temperate zones in the middle, and then the hot subtropical and tropical zones near the equator. What's so interesting is that Europe actually stretches across several of these major bands.
And here you can see the breakdown for Europe itself. Way up north, you have the polar zone. We're talking intense cold, ice, snow, the whole deal. The temperate zone covers that big chunk in the middle, giving it all 4 seasons. And then down south, the subtropical zone means it stays pretty warm for most of the year.
Okay, so this brings us to the crucial question. Why? Why is Northern Europe freezing while Southern Europe is getting a tan? What natural forces are actually drawing these invisible lines across the continent? Well, our prime suspect, as you probably guessed, is the sun. But it's not just the sun itself, it's really about the geometry of our round planet and its angle compared to those incredibly powerful solar rays.
So let's zoom in on the equator's role in all of this. This is the first major piece of our puzzle, and it explains that fundamental temperature difference between the north and the south.
It's a simple question we all kind of learn as kids, but the answer is absolutely key to understanding climate on a planetary scale. Why is the equator the hottest part of our world?
Well, it all comes down to the angle of attack. Because the Earth is a sphere, the sun's energy just doesn't hit every part of it with the same intensity.
Think about it like a flashlight. Near the equator, the sun's rays are hitting the Earth pretty much straight on, like a focused, intense beam of light and heat. But as you move up towards the poles, that same amount of energy hits the Earth at a much shallower angle, so it gets spread out over a much, much larger area. And that really weakens its warming power. But hang on a second. The sun's angle doesn't explain everything. If it did, a city like London would be as cold as Calgary, Canada, since they're at roughly the same latitude. But London's winters are pretty mild, while Calgary's average a bone-chilling -15 Celsius. The reason for this difference? Well, Europe has a secret accomplice, a hidden force that makes its climate way milder than it has any right to be.
So, meet our mystery accomplice, the Gulf Stream. Now, this isn't a river on land. It's a colossal current of warm water that flows through the Atlantic Ocean. And this is the plot twist in our story that makes Europe's climate so unique. The Gulf Stream actually starts in the warm waters of the Gulf of Mexico and the Caribbean. And it basically acts like a giant conveyor belt, shipping all that heat across the entire ocean right to the doorstep of Western and Northern Europe. It's a pretty simple 3-step process, really. First, the warm water travels north. As it moves, it heats up the air above it. And then, the winds that are usually blowing in that direction, the prevailing winds, they blow that warmed-up air over Europe, raising temperatures and making the whole climate way more comfortable than it would be otherwise. This is just the perfect way to think about it. The Gulf Stream is basically a massive, natural, central heating system for the whole continent. And it's working 24/7, constantly fighting off the extreme cold that you'd normally expect to find at these latitudes. So there you have it. Case closed. Europe's incredibly diverse climate isn't just because of one thing. It's 2 major factors working together. You have the fundamental global climate zones created by the Earth's curve, and then you have the continent's own special heating system, the Gulf Stream.
And this leads us to one last really crucial question. We know this massive current keeps Europe warm, but scientists have observed that it's changing. It's slowing down. So what happens if Europe's central heating system starts to fail? What will the climate of this continent look like then? Well, that's a mystery for another day.